Hi, welcome to this video, and in this video we are going to learn how to find the height of Mount Everest. In fact, we are just quickly going to reflect in past that how exactly the height of Mount Everest was identified by using these trigonometrical functions. So the story goes like this, that there are two mountaineers who actually decide to climb the Mount Everest and they start walking towards it. Now, one of the mountaineer sees from some place and the angle of elevation that the mountaineer is making with the peak of the Everest is 22 degrees, while there is another mountaineer who is 28.28 kilometers behind the first mountaineer, and he is able to make the angle of elevation as 10 degrees when he looks at the peak of the mountain. And this information is sufficient for us to find out the height of Mount Everest by using the trigonometrical functions. Now let's quickly see the magic of trigonometry here. So let's assume that the first mountaineer who is closer to the Mount Everest peak is at a distance of x meters from the Mount Everest peak. So let's take it in meters and let's convert this distance as well in meters. So this distance 28.28 kilometers, because 1 kilometer is equal to 1000 meters. So it is equivalent to 28280 meters, right? So the trigonometrical functions that we have to use here are the functions which should include the height and the base. That means the opposite and the adjacent. And we see that tan theta is equal to the opposite divided by adjacent. So we are using the tan function here. That means tan 22 degrees can be said equivalent to h over x. While on the other hand, for the other mountaineer who is making an angle of elevation of 10 degrees, tan of 10 degrees can be written as equivalent to h divided by x plus 28280, and everything is in meters. Remember that the distance that we are calculating are in meters. Now we have these two equations and our sole intention is to find the answer of this particular equation. We have two variables and we have two equations. That means we can simplify and find out the value of those variables. So what I am doing at first is I am dividing the equation 1 by equation second so that we can cancel out h, and at first we will have the value of x. Now when we take the ratio of these two things, we find that tan of 22 degrees divided by tan of 10 degrees will be equal to x plus 28280 divided by x, because this part goes above when we take the ratio. Now we have to find out tan of 22 degrees, tan of 10 degrees, and that is where we have to take the help of the calculator. So let me quickly just show you how to calculate these values. So tan of 22 degrees, we have 22. And now I am putting tan function here, so 0.404. That means we have 0.404 here in the numerator. Tan of 10 degrees, that means we have 10, and we are taking tan of it, it's in degrees, 0.176. So 0.176 is equal to x plus 28280 divided by x. Let's simplify this further. That means 0.404 divided by 0.176. 0.404 divided by 0.176 gives us 2.295. So we have 2.295x is equal to x plus 28280. That means we have 1.295x is equal to 28280. That means x comes out to be 28280 divided by 1.295. Let's quickly calculate that. So 28280 divided by 1.295, and that gives us 21837 or 21838. We can take x is equal to 21838 meters. That means the mountaineer who was making an angle of elevation of 22 degrees was at this much distance. Now this distance is good enough for us to find out the value of h, because you can substitute this value in this trigonometrical relation and find out the value of h. From this function we can say that h is equal to x multiplied by tan of 22 degrees. Now let's quickly calculate that. The value of x is 21838 multiplied by tan of 22 degrees. So we have 22, we are taking the tan function here, 0.404, and this needs to be multiplied with 21838. So 21838, and by simplifying this we find that 0.404 and the height comes out to be 8823, while the actual height of the Mount Everest is equal to 8848 meters. Initially, at first it was found to be 8840, but the internationally recognized height of Mount Everest is 8848, and this gives us a very close approximation because we have rounded off the values everywhere. So that is how we reach to the conclusion that what is the height of Mount Everest. So this particular example was taken just to demonstrate how the trigonometry can be used to find out the height of some places which are really difficult, and this is how you can imagine that how in astronomy we can find out the distance between the two planets, or the diameter of any particular planet, such as the diameter of Earth, the radius of Earth. So these are the things where the trigonometry has been instrumental, and it has quite great application out there. I hope you enjoyed learning how to make use of trigonometry in the real life example. Thank you so much.